Hi, and welcome back to another LeetCode easy problem. I've explained before that I like easy problems because they allow you to focus on the interviewing process and your communication and reasoning more than maybe a medium problem where you might get stuck in trying to solve the problem. So right now I'm just going through a couple of easy problems to practice my approach and to showcase it. So you've seen the previous videos, you know the drill. Step 1, read the problem. Step 2, check the constraints. Step 3, read through the examples. Step 4, come up with possible solutions, maybe solutions that have different trade-offs. Do the runtime analysis and space complexity analysis before you implement any code. Then put your idea into code that is hopefully Pythonic and easy to read with good variable naming, etc., etc. And then you step through a mental debugger to try to find any issues, off-by-one errors, index errors, or any typos that you might have made. And then comes the big moment of where you test your code against the test cases and then finally submit it. So that's what we're going to do in this one. I have not solved this one before. I have not seen this before, though this is my first time doing it. Let's see how it goes. Okay, so step 1. Let's read the problem description. You are given an integer array nums transform nums by performing the following operations in the exact order specified. All right. First, replace each even number with a 0. Second, replace each odd number with a 1. Sort the modified array in non-decreasing order. So that means the zeros before the ones. Return the resulting array after performing these operations. Cool. Constraints. Typically for LeetCode, you have some constraints on the input. For our runtime analysis, we will pretend that the input is unlimited and has n elements. Otherwise, runtime complexity is constant, as well as space complexity. And so what is interesting here, we have at least one element in nums, right? So we don't have to take off the edge case of where the array is empty. And then we have some information about the different values in that array. And it's positive numbers and no zeros, and between 1 and 1000 inclusive. Cool. I think we already have a pretty good understanding of what we need to do, but just for the sake of completeness, let's just go through the examples. Input nums, 4, 3, 2, 1. So the first step would be replace even numbers with 0. So this would be 0, that. And the second is replace that and that with a 1. So we'd have an array that has 2 1s and 2 zeros in alternating order. And then we sort it. Cool. Now, I'm immediately thinking that, we will just do a 1 pass through the array, identify how many odd and how many even numbers there are, and then we just build our output array. So we don't have to do any sorting, right? We know that 2 even numbers and 2 odd numbers. Easy peasy. Second example. So we have 3 odd numbers and 2 even numbers. So 2 zeros and 3 ones. Yeah, I think we've understood the problem. So that's going to be easy to implement. We will have an O of n time and space solution. We need O of n time to iterate through the array to determine the number of even and odd numbers. And we need to have n elements in our output. That is the concatenation of the zeros and the ones that we have here. So yeah, so let's just write that down. O of n space and time, or time and space, right? Time and space, where n is the length of the array. And I'm just going to have a counter. And that counter counts the even and the odd elements. So now I'm just going to iterate through our array for n in nums. And then we're going to increase the counter at what position? Well, if we take the modulus of n, it will give us 0 if the number is even, and it will give us 1 when the number is odd. So that's what we'll do. So at 0 will be the number of even elements. At position 1 in our counter array will be the number of odd elements. And then all we need to do to return is we have to return the 0 times counter at position 0. We just do a list concatenation. and the number of ones at that we counted. So that should be everything. And yeah, I bet there's somebody who did a one-liner on this, but I don't think it's really necessary. And if you want to be able to explain your code, this is good enough. Why not, right? So let's run it to make sure I didn't make any mistakes. And it looks good. Both in our examples, we get the right result. Let's just have one more look at the edge cases. So we might only have one. So what will happen if the counter is 0? I'm not sure what will happen, but I would assume that this is an empty list. Let's hope that Python developers thought of this and made it so. I'm just gonna take my chances here. And oops, I have to submit this. Shaboom. Very nice. So that's that. Oh, final step. It's always good practice to look at other people's solutions. Maybe we see something interesting. So something with a constant space that's already, oh, of course. Well, why is this constant space here? Write the zeros. Aha, so this person was smart enough to overwrite the nums array. So that means that person had constant space because it just reused the input. Actually, that's not a bad idea. And you should ask your interviewer if you can reuse the array to return the output. Sometimes you must not use the input, but actually here in the problem, and I should have seen this, should have paid attention. We're actually operating on the array. So that's a dead giveaway that we can actually manipulate it. So let's optimize our solution. And what we'll do is for I in, well, we will just overwrite the values here in nums. So what we do is while counter in 0, let me just see. But we need to iterate over all of them elements, right? So we start at 0. And well, we just could do this for in range counter 0. We're just going to write to nums at position idx plus delta is equal to 0, right? And we don't actually have to do that. We just do the idx and just increase our index after. And after that, we do the same thing for those elements that we have in our odd counter. Right. Yes, we could do something like that. Could submit it. And now we're done to O of 1 space. Nice. Okay, so that's an optimization. Now we could probably make this even nicer. You know, we could, as soon, do this in a single pass as well. So as soon as we run into an even number, we're going to increase our index. So if n is 0, we're going to write the 0 into the position. It's kind of like a left and a right pointer. Maybe I should use the left. So left is 0. Right is this. And so we have 2 pointers. The left one points to the last 0 we've written. And then finally, after we've looped over all of the elements, we know that the remaining elements in our array from the left position are all need to be ones, right? So we do while left smaller than nums. Nums at left is equal to 1, left is +1. Let's see. Yeah, and that should also work. Cool. Yeah. So learning from this, well, consider if you can modify the array. And if the problem states it right away, that's exactly what you should do. So yeah, cool. That concludes this little example, and have fun coding it.